Welcome back, everyone. Today we're going to discuss about the transformation of square root function. Before we begin, I would like to remind you the square root parent function, which is y equals square root of x. For better understanding and appreciation of this lesson, I would like to use Desmos mostly on this presentation. Our first transformation is f of x plus d, where the d is outside of the parentheses. According to this table, it is a vertical translation up by the units. Okay, let's take a look at the graphs on Desmos. All right, so to begin with, this is our graph of the parent function. So what happens if you add a number outside of the radical sign? Now, please remember that the radical sign serves like a parenthesis somewhat, that it is enclosing whatever is inside of that radical sign. So in the table that you have seen, whenever the function has the parentheses, like f of x has a parenthesis, this radical serves like that. It is like your parentheses. So your number is, let's say it's outside. Okay, so let's say it's plus 3. All right, so as you can see, your original parent function had translated 3 units up. So that is the effect of that transformation in the parent function. Now let us discuss the next transformation, which is a minus d. That's again outside of the radical sign in this case. So it is said to be a vertical translation down by the unit. So let's take a look at this on Desmos. All right. So again, this is your parent function. What happens if the plus changes to a minus? There you go. So as you can see from your original parent function, your graph now has shifted 3 units down. All right. So now at this point, I would like to wrap up this vertical translation. So now, once again, this is your parent function. And if you are adding, and let's say you are adding 5 outside of the parentheses, and in this case, outside of your radical, you are going to shift up by that many units. So once again, this adding or subtracting affects the y values, which is why it is vertical. So now let's take a look at whenever you're minusing, your graph is sliding down. So a couple of vocab that I want you to remember: translate, slide, shift are all the same. All right, let us now go to our third transformation, which is the horizontal translation to the left by C units. And that one would look like this, where the plus C is inside the parentheses. But since we're talking about radicals, the plus C is going to be inside the radical sign. So once again, we are going to start with our parent function. Let's go ahead and start assembling this. All right. So what I did was I just wrote x plus 5, which is inside the radical sign. Please remember once again that this radical serves like your parentheses. So therefore, the plus 5 is technically on our table like inside the parentheses. So when that happens, anything that happens inside the parentheses affects the x values. So it is affecting that horizontal axis, which is the same as the x-axis. So therefore, everything that happens inside as well is the opposite. You do the opposite. If it says plus 5, then that is going to move 5 units to the left. If it says minus 5, then you will have to move 5 units to the right. So in this case, from our parent function, you can see that the slide had been 5 units to the left. For our fourth transformation, it says that it's the horizontal translation to the right by C units. What you will see is inside the parentheses, you will have a minus. And once again, let me remind you, this is radical. So inside the radical is a minus C. All right, now let's play with Desmos right now. So that is your parent function. Let me put minus, let's say 4. All right, so as you can see from your parent function, which is represented by this red graph, it had translated 4 units to the right. Our next transformation is the reflection over the x-axis. This happens when your negative sign is in front of your fraction. Once again, outside of the parentheses. The common misconception of students is that whenever it says that it's reflection over the x-axis, they think that it's the x values that you are reflecting. But as you can see, as stated on this table, the y values are the ones that you are reflecting. So let me try to explain this one more time. Reflection over the x axis is like the x axis is your line where your values are reflecting over that line. So it's reflecting about the x axis means that your y values are the ones that are getting reflected. All right, so once again, let's go ahead and put that negative right there. All right, so as you can see, the graphs are reflecting about the x-axis or across or over the x-axis, but actually all the positive y values that you have on your parent function now are negative y values. So let's go ahead and play with this. What if I don't have a parent function? What if I have something else? Let's say this, okay? And then you have a negative. All right, so as you can see, it will still follow the graph along the x-axis. Next transformation is the reflection over the y-axis. And when this happens, you are reflecting the x value. So the positive x becomes negative and vice versa. So now this happens whenever your negative is inside the parentheses. So therefore, in this case, it has to be inside the radical. And whatever is the expression that's inside the radical should all be enclosed in parentheses, and in the front of that be the negative sign. Let's check out Desmos. Right, so let's try putting a negative here in the front. And as you can see, your graphs are reflecting about the y-axis. Therefore, all these positive x values from your parent function are now going to become negative x values. So, but what happens if we don't have a parent function? So let us observe that. So let us pretend that this is our given function and it's not a parent function. It is y equals square root of all inside the radical x plus 2. So what happens if I do this? Now you can see that your parent function, or sorry, your graph had been reflected to the other side, but this time not anymore over the y-axis. This is now reflected over the x equals negative 2 line. So let's type that up. X equals negative 2 line. Our next transformation is the vertical stretch and compress. Vertical stretch or compress happens whenever you multiply a number to your function. If your number is greater than 1, then you are vertically stretching your function. If your number is less than 1 but greater than 0, which I always explain this to kids, imagine a fraction that is less than 1. For example, 2/3, 1/2, 1/4, 2/5. Those will result to a compression. So once again, this happens when you multiply a number in front of your function. I would like you to watch a short clip in order for you to at least imagine what's happening to your graph when you are vertically compressing your graph. What's happening is you're squeezing it, so it becomes wider. Okay, so that happens when you are compressing vertically your object. All right, now let's take a look at your parent function. Now I had put here a number that is bigger than 1. So let's see what happens. There you go. So it's been vertically stretched. Now, what happens if you have put a number that is less than 1 but greater than 0? Let's say 1/5. You have vertically compressed it. So this is like what happened to the car. Okay, you vertically compress it. So there you go. If this number is greater than 0 but less than 1, it is a vertical compression. And whenever it's greater than 1, it is a vertical stretch. Again, this happens if your numbers are multiplied but outside of the parentheses. In this case, outside of the radical sign. Our last and final transformation. Again, a number is being multiplied, but this time inside the parentheses. And in this particular lesson, it's inside the radical sign. Whenever it is inside the radical sign, it affects all the x values, therefore, all the horizontal values, which is now this time, this is a horizontal compression. If your number is bigger than 1, please take note. Everything that happens inside the parentheses, you do the opposite. So if this is bigger than 1 inside the parentheses, that is really a horizontal compression. If it's less than 1 but greater than 0, which means again 1/2, 2/3, 1/3, 1/4, this will be a horizontal stretch. So once again, you are doing the opposite whenever it is happening inside the parentheses, which in this case, inside the radical sign. Let us watch a short video clip in order for you to visualize what's happening whenever you're doing a horizontal compression and stretching. All right, so what I want you to observe is this is what's happening, that is compressed right there, horizontal compression, and this is stretch. When you open it up horizontally, that's a stretch, that's a compress. All right, now graphically, let's go ahead and show this. Again, the red graph is your parent function. And what happens if I put a number and multiply it inside the parentheses, a number that is bigger than 1? What happens is it is horizontally compressing it. It's squeezing it horizontally, which means that this blue line is produced. Now, the way to say this is that it's been horizontally compressed with a factor of 1 over 7. So, again, the inverse of whatever happens inside, guys, you do the opposite. So, this is a horizontal compression with a factor of 1 out of 7. All right, now let us discuss the horizontal stretch. So this is a horizontal stretch right there. So what happens is your graph is being stretched, but horizontally. And happens whenever your factor inside your parentheses, or in this case, inside the radical sign, is greater than 0, but less than 1. The way to say this is your graph from the parent function had been horizontally stretched with a factor of 5. So you're doing the inverse. Right, guys? I hope that you have learned a lot today, and I hope that you enjoy working on your transformation of square root functions.